So you guys, let's do a question. And this is the question that I have chosen from quantum mechanics. Okay. And this numerical is very interesting in its way. You can see that what it is asking. It is asking us that a proton and deuteron have the same kinetic energy. Okay. And which will have the longer wavelength. And this is very interesting question. What it is saying actually, it is saying that proton and our deuteron both are moving with the same kinetic energy. Kinetic energy means what? The energy which it is acquiring during its motion. Okay, that is kinetic energy. So the question is saying that kinetic energy is same for both proton and deuteron. Okay, so we have to find out what's the wavelength, guys. uh, to solve this question we have to understand the two concept. Okay, dual motion means nothing, it's the de Broglie wave equation, that is lambda is equal to Planck's constant upon the momentum. Okay, it means that when a particle is moving, okay, it consists two kind of motion. First is it consists two kind of nature. First is particle nature and another is a wave nature. Means when a particle is moving, it moves in the form of wave. Okay, so that's exactly what the question is asking. Okay, it is asking that proton and deuteron, okay, have the same kinetic energy. So we have to derive or we have to calculate the relation. Okay, whose wavelength will be longer. Okay, longer wavelength means less frequency. Okay, you can easily solve this question by this expression. Okay, that is lambda is equal to h over mv. Okay, we know that mass of proton, let's say it is m. Okay, and we exactly know that the mass of deuteron is always twice of the proton. Okay, that is 2m. So by these two concept, okay, by knowing exactly what is the mass of proton and deuteron and by simply applying de Broglie wave equation, okay, so that is this. So you can see the one which have the lesser mass, that will have greater wavelength. Okay, it means that wavelength is inversely proportional to the mass. Through this relation we can easily derive, okay, that if the mass of the proton, we know that mass of the proton is small, it means that its wavelength will be longer, and mass of the deuteron is large. Okay, it means its wavelength will be small. It means that as your mass of the particle will increase, okay, the wave exist with that particle, okay, that will decrease. Means that the wavelength which exists with that particle, that will decrease. Okay, this is the general. Okay, we can say through this formula only this thing, that okay, the mass of the proton is small, so it means that longer wavelength should be of proton, but we don't know exactly how much larger it is as compared to the deuteron wavelength. Okay, so to derive that how much longer or how much larger the wavelength of the proton is as compared to deuteron, let's go further. And we will use two step process here. First step is we will equate the kinetic energy of both proton and kinetic energy of deuteron. Okay, through this we will follow and we will apply rapidly the same equation of the de Broglie. Okay, that is this h over mv. By these two steps, okay, we will easily find out that how much larger is the wavelength of the proton as compared to the wavelength of the deuteron. Okay, so let's start. So kinetic energy of the proton is what? 1 over 2 m p. Mp is nothing, guys, it is the mass of the proton. Okay, let me write here so you don't get confused. It is the mass of proton. Okay, and let's say that mv square, and let's say that this is also p square. Okay, vp is nothing, it is the velocity of the proton. Okay, and let's say that md is nothing, it is the mass of deuteron. Okay, and let's say vd is equal to nothing, it's nothing, it's the velocity of deuteron. Okay, so this is the parameter that we have. Okay, so it means what the condition that is already be given to us, that is kinetic energy of the proton is equal to kinetic energy of deuteron. Okay, I am just repeating or writing that in a different form. Okay, this is the kinetic energy equation for proton, and 1 over m d v d square. Okay, this is for proton and this is for deuteron. So guys, as you know that kinetic energy is nothing, it's just 1 over 2 half of the mv square. Okay, so same thing I had written here, there is nothing so much difficult or complex things to understand. Okay, you just have to equate all these equations. So now let me do it further. It will be 1 over 2 m p v p square is equal to what? It will be 1 over 2 m p vd square. Now you will get confused from where we get this 2 mp, guys. Don't get confused. This is the kinetic energy of deuteron, and we had already studied that deuteron mass is always the twice of the mass of the proton. It means that md, mass of the deuteron, will be equal to the 2 into mp. So I had done nothing, I just replaced the value of md from twice of the mp. Okay, so that our calculation will get easy. Okay, let's do it further. And if we do it further, then let's cancel out this and let's cancel out this. So we will get exactly vd is equal to 1 over under root 2 vp. This is the relation that we got from the kinetic energy, guys. I told you that any kind of the numerical you face, okay, first of all use the condition that is given in the questions and then apply that in a different format. Okay, so that the condition which is given in the question, that is just input. Okay, we have to put this input now in the de Broglie wave equation so that we will get the final result. Final result is the what? How much longer the wavelength that exists with the proton, okay, that is greater as compared to what? Our wavelength which is existing with deuteron. Okay, let's calculate that. This is the velocity relation that we got. If we got the velocity relation, then we can easily find out that how much larger the wavelength is. How we can find out that? Through the use of de Broglie wavelength equation. Okay, so let's do it further, guys. So let me write it again. vd is equal to 1 over under root 2 vp. Okay, so by using, I'm using now second step, guys, by using de Broglie. Okay, de Broglie wave equation. So this is our de Broglie wave equation, h over m vp. This is, let's say, for proton. Okay, and as we know that what will be lambda d, it will be h over m v d. Okay, now we know that what is the value of mvd. Okay, put the value of vd here and put the value here. Okay, you will get at the end that lambda d over lambda p. I'm not doing it further because it's too easy to do it further. Okay, so from here you can easily calculate that lambda p, okay, wavelength of the proton is under root 2 times of wavelength of deuteron. Okay, this is the final relation that we got. Okay, it means that lambda p is equal to under root 2 lambda d. Okay, so this is the relation that we got. Let's suppose that if the wavelength of the deuteron is let's say 4, okay, and what say 4 meter or something. I'm just, don't take it like it's exactly, okay, it's just a explanation or an example that I'm giving you. Let's say it's a 4, so what will be the wavelength that will exist with the proton? Okay, that will be under root 2 multiply 4. Okay, so this will be 4 under root 2. So this is the wavelength. It means that the wavelength of the proton will be always greater than the deuteron. It doesn't mean that it will be always greater than. It's the condition when the kinetic energy of the both the proton and deuteron is same. Only in that condition this relation will apply. Okay, I hope you like this video, and if you like our initiative, then give a thumbs up and do subscribe our channel. Thank you so much.